Today we're going to talk about a technology that plays by the absolutely bizarre rules of the subatomic world. It's a technology that's really poised to redefine, well, pretty much everything from medicine to money. We're talking about quantum technology.
So, why should you care? Well, according to a recent report, by 2035, quantum tech is on track to unlock an economic value of nearly $2 trillion. Yeah, that's trillion with a T. This isn't some far-off science experiment. It's an economic revolution that's just getting started.
And this isn't just some future guess. I mean, the money is pouring in right now. We're seeing this massive surge in investment. Governments are committing over $42 billion in venture capital. They're throwing in another $8.5 billion on top of that. This isn't a marathon, folks. It's a global sprint, and the race is definitely on.
So what exactly is this technology that's worth trillions of dollars? What makes it so different, so powerful, that entire countries and the smartest investors are basically betting the farm on it? Well, it all starts with a completely different way of thinking about information. See, the magic here isn't just about making our computers faster, it's about building them from the ground up based on a totally new set of rules, the strange and frankly wonderful rules of quantum mechanics.
Okay, so your phone, your laptop, every computer you've ever used runs on bits. Just think of a bit like a standard light switch. It's either off, which we call a 0, or it's on, which we call a 1. It has to be one or the other. But a quantum bit, or a qubit, now that's more like a dimmer switch. It can be 0, it can be 1, or, and this is the part that changes everything, it can be a mix of both, 0 and 1 at the exact same time.
And this wild dimmer switch idea actually has a name: superposition. It's this counterintuitive kind of mind-bending ability for a tiny particle to be in multiple states at once. And that right there, that's the secret sauce. It's the foundational source of a quantum computer's insane power.
And here's where it gets really crazy. It's all about scaling up. So while 2 normal bits can only hold one of 4 possible combinations, 2 qubits in superposition can process all 4 of those possibilities at the same time. You add a third qubit, now you're processing 8 possibilities at once. This power doesn't just add up, it grows exponentially.
And when you have that kind of exponential power, you can start to tackle problems that are, well, completely impossible for even the biggest, baddest supercomputers on the planet today. We're talking about problems we once thought were basically unsolvable.
So what kind of problems are we talking about? Well, imagine perfectly simulating complex molecules to invent new life-saving drugs or revolutionary materials, or optimizing the entire global supply chain, finding the best route for every single ship on the ocean all at once. And yeah, there's also the big one, breaking the very encryption that keeps most of our digital world secure today. And let me be clear, this isn't science fiction, it's already happening. In a huge demonstration, Google's Sycamore quantum processor did a calculation in 200 seconds. The world's fastest supercomputer? It would need about 10,000 years to do that same calculation. That was the first big taste of what we call quantum advantage, the point where a quantum computer does something a classical computer just can't.
This points us to one of the most exciting areas. I mean, the molecules that make up our world, our bodies, everything, they're all governed by the laws of quantum mechanics. So what better tool could we have to understand them than a computer that literally speaks their language? This could unlock cures for diseases and create materials we can't even dream of yet.
But listen, quantum isn't just about building monster computers. The same weird principles are sparking revolutions in 2 other huge fields: secure communication and hypersensitive sensors.
First, quantum communication. This promises something that sounds impossible: truly unhackable communication. Here's how it works. The very act of a spy trying to look at a quantum message changes it. The particles themselves are the burglar alarm. You'd instantly know someone was trying to listen in.
And then you have quantum sensing. See, quantum states are incredibly fragile. They're super sensitive to their environment. Now, that's a huge pain if you're trying to build a stable computer. But if you're trying to build a sensor, it's a massive advantage. We can harness that sensitivity to measure the world around us with the precision we've just never had before.
Just think about medical imaging for a second. Quantum sensors could lead to MRIs that are so sensitive they could watch the metabolism of a single cell in real time. We could spot diseases way earlier than we can today.
Or what about navigation? You could have quantum clocks and gyroscopes that are so accurate, a submarine or a self-driving car could know exactly where it is for weeks, even if it completely loses its GPS signal. So how in the world can something be that sensitive? How does any of this work? Well, it all goes back to the fact that quantum particles just behave in ways that seem to break all the rules of common sense. And to get it, we have to look at one of the weirdest effects in all of physics.
Okay, just think about our normal, everyday world for a second. If you roll a ball at a hill, but you don't give it enough of a push to get over the top, what happens? It rolls back down, every single time. It can't just magically pop up on the other side, right? That's impossible.
But in the quantum world, the rules are completely different. A particle, like an electron, can run into an energy barrier it shouldn't be able to cross, and sometimes it just does. It tunnels right through to the other side, like the barrier wasn't even there. And here's the kicker. This isn't just some weird theory. You've already used this. This impossible quantum tunneling is exactly how the flash memory in your USB drive or your phone actually works. It's literally quantum mechanics in your pocket.
Okay, so we've seen the mind-bending principles and the incredible potential. But where are we right now on this journey? What does the road ahead really look like to make this all a widespread reality?
We have to be realistic, of course. This future isn't going to show up overnight. There are some major challenges to solve. That same sensitivity that makes quantum sensors so amazing also makes quantum computers incredibly fragile. Keeping qubits stable and free from all the noise in the environment is a huge engineering puzzle. We also have to figure out how to scale from the hundreds of qubits we have today to the millions we'll need. And honestly, we just need more people who know how to build and program these incredible machines.
You can think of the journey in a few stages. Right now, we're in what's called the NISQ era. That stands for Noisy Intermediate Scale Quantum. Our devices are powerful, but they're still kind of small and prone to errors. The next big milestone is quantum advantage, where these machines start solving real-world, valuable problems that our best supercomputers just can't handle. And the ultimate goal? The fault-tolerant era, with large, stable, error-corrected quantum computers that can take on pretty much anything we can imagine.
From brand new medicines to totally unhackable data to a fundamentally deeper understanding of our universe, quantum technology is going to redefine what's possible. The only question left is, where do you think you'll see its impact first?